All right, here we go. Lesson number 2 of the week. Go ahead and get out your homework. Let's take a look at it. So it was 10.7, page 407, 408, 1 through 12 all. Most of these are drawings. I'm just going to highlight 2 of the problems. We'll do a couple, or we'll do 5 through 10. That's what I'll call out. All right, take a look at what you put for number 5 and 10. 5 through 10. All right, number 5. The answer is the intersection of circle P with a radius of 3 centimeters, and line L would be 2 points. 2 points. 2 points is the answer. All right, number 6. The intersection of circle Q with a radius of 5 centimeters and 2 lines parallel to L and 3 centimeters from L would be 4 points of intersections. 4 points of intersection. Number 7, the intersection of circle A with a radius of 2 and circle B with a radius of 2 would be 2 points. 2 points, 2 points. Number 8, the intersection of circle P with a radius of 2 and the bisector of the angles formed by J and K would be 4 points. 4 points. Number 9, the intersection of circle A with a radius of 2 and the bisector of angle A would be 1 point. 1 point. And number 10, the intersect of the bisector of angle R and the perpendicular bisector of segment RS would be 1 point. 1 point. Cool? All right. Some of these are a bit more challenging than others. Don't get too frustrated. Some will require you to, do a little spatial thinking before you actually draw the picture. For me, generally, like I said, I just draw the first condition and the second condition, and then put those together to determine what the loci are. Okay. Go ahead and go to Google Forms, pause the video, go to the Google Forms, and answer question number 1, which is basically how many you got wrong. Okay. Calendar, we're going to do 10.8 today. That's the end of the chapter. Tomorrow we'll do a quick chapter review. Typically, if we were doing this in the classroom, this would just be a whole lot of constructions. The test would have been just constructions, including the loci ones. You'd have to construct what it was. Since we're not going to do the test, we'll just do some practice constructions tomorrow and call it good for that chapter and move on to chapter 11. Unless things change, when we get back, we'll do PSAT prep from spring break, and then we'll move on from there. All right, your homework tonight, just 1 through 8, 1 through 8. These are the hardest constructions of the loci problems. Paradoxically, since these are the hardest ones, we're going to do some of the fewest examples. In fact, we're just going to do one example. All right, loci and construction. So we've done loci. I mean, technically we have done constructions. We've just freehand them. Now they literally want you to do these constructions with your compass and straight edge. So go ahead and get out your compass and straight edge. We're going to do one example. One example. There's your objective of the day. All right, just one problem. One problem. Here it is. You're given an angle, in this case angle N, and you're given 2 segment lengths. One is bigger than the other one. One is labeled length of R, and one is the length of S. So one angle, 2 different size segments. The conditions, well, there's a few of them. All right. First off, it says construct triangle ABC. Technically, that's what the loci is going to be. It's going to be ABC. But they have 3 conditions. First off, the measure of angle A has to be equal to N. In other words, the measure of angle N, you're just copying angle N over. And then it says AB, one of the sides of the triangle, is equal to R. And it says, well, it doesn't talk about the third side or even the second side. It talks about an altitude. So it says the altitude to side AB has a length of S. So S isn't even a length of the triangle, but it is an altitude. Sounds complicated. As we did yesterday, it's much more easier to do it one piece at a time, and everything will fall through from that. Okay, so here's what I want you to do. Obviously, you can make your R and your S any side. Don't make them about what I did, just so for convenience. Get a clean sheet of paper, and here's the basic setup. Right? If you were in class, this is the sheet I would hand you. All right, now we're going to use everything that we've learned in this chapter for construction. So we'll just do it one piece at a time. All right, so it says construct triangle ABC. So we're going to get a triangle. And the first condition, well, technically it's the second one, but the first real condition is that angle A is going to have the same angle measurement as angle N. So since we're given, there's the picture. Now you were to draw any angle you want. You could have drawn it obtuse if you want. I guess you couldn't draw it 180 degrees, could you? So anything less than 180 degrees, don't make an obtuse one. It just makes your life hard. All right, so just make an acute angle. Make a segment of length R, make a segment length S, make one bigger than the other. Okay, once that's done, we're going to construct angle A. Now, angle A is just a copy of angle N, so we're going to use whichever construction that was. I believe that was construction 2. Construction 2 to make a congruent angle. Okay, I am not in this demonstration going to show you all the tick marks. My assumption is that you remember how to make a congruent angle. Now notice my congruent angle, one of the legs is really long. In fact, it should be both really long. So give yourself enough space so that you can work with this particular triangle. So somewhere on there, there's one angle of the triangle. And I just obviously made a copy in PowerPoint, but you guys should be pretty good on making or constructing congruent angles at this point. Okay, so let's see. We're done with the first condition. The second condition says AB, so side AB has to have the length of R. So take your compass and measure how long R is. I'm going to use the bottom ray of the angle. You could use top or bottom, but if we all use the same one, it just makes it a little bit easier. So I'm going to measure out on the bottom ray of the angle, or the bottom leg of the angle, that distance, which is how long R is. And then I'm going to label it AB. Everybody remember how to do that? Good. Okay. So we've done one condition, we've done two conditions. All we got to do is that third condition, which is we got to make an altitude to AB having the length of S. That's a challenge. So somewhere along AB is the altitude, and that altitude would go to the vertex C, and C would be somewhere on that. That ray that goes up from A that isn't labeled yet. Okay. The question is, where does it go? I mean, we could guess and check. As long as it's perpendicular, we would have the right answer. But we don't know where it resides. So we're going to do a little trick. So here's what I want you to do. On the other side of B, I want you to. And I labeled that length R. Sorry. So somewhere along to the right of B, I want you to label another point. And it doesn't matter which or how far away from B you are. I just put it close to the end. And what we're going to do, you'll see why here in a second while we're doing this. What we're going to do is we're going to make a perpendicular through that point. So whatever number construction this was, 3, 4, or 5, we're going to make a perpendicular through that point. We'll call that point E. Okay? Because remember, we've got to keep C for the triangle. All right, so I'm going to make a perpendicular. Remember how to do that. Once you make that perpendicular right there, we're good. Everybody good? One thing I noticed when I'm doing this video, I should have extended AB out much further than that. Because remember, when you make a perpendicular, the first thing you do is make arc intersections from point E on both sides of the segment. And clearly on mine, I couldn't have done that. But hopefully you did it correctly. All right. So here's what we do. Here's the trick and the reason why we made this perpendicular. We're going to take our compass and we're going to measure segment S. See where S is? Now yours might not be as long as mine was, or it might be shorter. We're going to take our compass, measure S, and then along from point E, we're going to measure that distance. Okay, and we will label that, I don't know, we'll call it F. Okay, and that distance right there is S. The trick to this, because remember, an altitude comes down at a perpendicular, and since we just made a perpendicular, all we need to do now is create a line that is parallel to AB that goes through F. If we make a parallel that goes through F that is parallel to AB, then anywhere along that segment that you just made, well, it's going to be the height of S. And notice now it intersects that second ray of angle A. So if we now connect point B to that point right there, that would be our C, we have our triangle. And you're like, well, I'm not sure why we did that thing with S. The reason why is because we wanted the altitude, there's the altitude, to be that same distance. If we had not made that line parallel, then the distance would not be the same. But since we made it parallel, we are assured that that dotted line that I just made has a distance of S. So let's see if we met all our conditions. Well, clearly we have a triangle ABC. It says that AB has to have the length of R, check. And it says that altitude to AB, so the altitude would come from C, perpendicular to AB. Well, we did that. And it also has a length of S. Okay, so the one part that you have to do is you have to make a perpendicular through C all the way through R. And ladies and gentlemen, you just met all, I mean, technically it's three conditions to make that loci. So this one was very detailed, very messy, which is also why I only assigned you 8 of these tonight for homework. If you run into any problems tonight when you're doing your homework, don't hesitate to give me an email. I'll give you a hint of what you need to do. Or if you have any other questions as well too. So hang tough, guys. Do your homework, and I will see you guys tomorrow.